Hello students, we are discussing integration by partial fraction. Let's see what is in store in this particular module. The question says evaluate the integral dx upon x minus 1 the whole square into x plus 1. Let's see the solution. Now my dear students, after I copy the question, I realize that I have a x minus 1 the whole square in the denominator. X minus 1 is linear, but it is repeated twice. I have two terms which are x minus 1 and x minus 1. So I need to adjust. I need to do something about it. This is nothing but I have a case of repeated linear factor, and this is our exception too. Repeated linear factor is not allowed in partial fraction, but we'll bend the rules little bit. Now what is the approach? If I have a rational form which says px square plus qx plus 3 upon x minus a into x minus b the whole square, then corresponding partial form will be a upon x minus a plus b upon x minus b plus c upon x minus b the whole square. That is the factor which is repeated. You need to write those many terms as many times it is repeated. Let's understand by applying it in this particular question. So 1 upon x plus 1 x minus 1 the whole square into x plus 1 will be written as. Now my dear students, x plus 1 is a distinct linear factor. That is, it follows all the rules. So it gets a standard treatment. We will assume it to be equal to a upon x plus 1 in the partial form. Now x minus 1 is repeated twice. So there will be two terms corresponding to x minus 1. The first will be b upon x minus 1. The second will be c upon x minus 1 the whole square. Because x minus 1 is repeated twice, you will have two terms corresponding to it, where you will increase the power by 1 in the second term. Had it been repeated 3 times, then you would have b upon x minus 1, c upon x minus 1 the whole square, and d upon x minus 1 the whole cube. But don't worry students, you will not have a factor repeated 3 times. It will be very time consuming to solve. Now after this, the method remains the same. Take LCM. So we get 1 is equal to a into x minus 1 the whole square plus b into x plus 1 into x minus 1 plus c into x plus 1. Now first we can find the value of a, and to find the value of a, what we need to do is put the value of x as equal to minus 1, because b and c have multiplication with x plus 1. So let's put x is equal to minus 1. What we get is 1 is equal to a into minus 1 the whole square. That is nothing but a is equal to 1 by 4. Correct? Now after we get the value of a, in this type of sums we will be able to get the value of c. Now to get the value of c, what we are going to do is we'll put x is equal to 1. So if I put x is equal to 1, on the left hand side I get 1 is equal to, on the right hand side I get c into 1 plus 1. That is nothing but c is equal to half. We've got the value of a, we've got the value of c. To get the value of b, again we make use of some other value of x, and that is x equal to 0 for simpler calculation. What do we get on the left hand side? Left hand side remains as 1. Right hand side becomes a into minus 1 the whole square plus b into minus 1 to be very precise, and c into 1. So that is 1 is equal to a minus b plus c. That is what we are going to get. Now my dear students, we know the value of a. So let us write 1 is equal to 1 by 4 minus b plus c is half. Now let us find the value of b. So that is nothing but 1 minus 1 by 4 minus half is equal to minus of b, or can I say b is minus 1 by 4. We found out the values of a, b and c. This is our partial form. It is a upon x plus 1 plus b upon x minus 1 and c upon x minus 1 the whole square. And the values of a, b and c are known to us. So what will the integral look like? So 1 upon x plus 1 into x minus 1 the whole square will be written as equal to 1 by 4 upon x plus 1. Then value of b is minus 1 by 4 upon x minus 1 and minus or plus half upon x minus 1 the whole square. Now can I say the integral will therefore become equal to 1 by 4 upon x plus 1 plus minus 1 by 4 upon x minus 1 plus 1 by 2 upon x minus 1 the whole square and a dx. Let's separate the integral. So we'll get 1 by 4 integral 1 upon x plus 1 dx minus of 1 by 4 integral 1 upon x minus 1 dx and a plus 1 by 2 integral of, can I write it as x minus 1 the whole raised to minus 2, correct? So now my dear students, the first two integrals are in the form of 1 by x. So let us write the formula and let us apply it. So 1 by 4 log mod of x plus 1. Likewise for the second one, minus 1 by 4 log mod of x minus 1. And now x minus 1 raised to minus 2 is of the form x raised to n. So as per the formula, what I'll get is 1 by 2 into x minus 1 raised to minus 1 upon minus 1. That is nothing but minus of 1 upon x minus 1 plus c. Now let us simplify the answer, my dear students. What we'll get is 1 by 4 will be common to the last two terms, right? So what we'll get is 1 by 4 log mod of x plus 1 minus log mod of x minus 1 minus of 1 by 2 into x minus 1, correct? Plus c has to be there. Now the first two terms here have a 1 by 4 common. They are of the form log a minus log b. So let us write that as 1 by 4 log mod of a by b. So log mod of x plus 1 upon x minus 1 minus of 1 by 2 into x minus 1 plus c. No further simplification possible. That's your final answer. Now, based on this, you need to practice these two sums. Very, very important for us from the exam point of view. That's all we have in this module. Thank you very much.